So before we move on, I want us to go through something we call standard integrals. So since integration is the reverse process of differentiation, the standard integrals, I'll be listing them over here, and we may be deduced and readily checked by differentiation. So if you want to check whether those are correct or valid, you can use your differentiation skills that you have done, I hope, in calculus 1 to verify those standard integrals. So without taking much time, let's go through these standard integrals, and you have to take note that these standard integrals are mostly, they are standard over there, like they're already there. So the only thing that you need to know is you have to get them on your fingertips. Wherever you encounter such integral, you just get them there straight away. And as I promised, I'll get time and then pick integration and differentiation of trigonometric functions, the limb functions, and then the exponential functions, and treat them as a separate topic as well. I think many people have problem in differentiating such functions or integrating such functions, and if you are able to differentiate or integrate such functions, this, when they combine them together as a questions for you, you are not going to find yourself wanting. So in going through the standard integral, let's pick the first one. The first one that we want to use is the integral of ax power n dx equal to ax power n plus 1 over n plus 1 plus c. So I think we have already discussed this. Wherever you see a multiplied by x power n, this is how we integrate it, and actually it's the power rule. Except when, so let me do this, except when n is not equal to, let me say, except n is equal to, let me say, 1. Except n is equal to negative 1. So if n is equal to negative 1, please, you don't use the power rule for it. That comes to deal with the limb. That's where you are going to get the limb x. So take very good note of it. So the second standard integral is the integral of cos a x dx. And as I said, when you get a trigonometric function like this, what you need to do is that differentiate whatever is inside the brackets, and then you divide. If it's if we are dealing with differentiation, when we differentiate whatever is in the bracket, we multiply by. Since we are dealing with integration, when you differentiate whatever is in the bracket, we divide. When we differentiate ax, we are going to get a, and therefore we are going to get 1 over a, as I said, divide, and then multiply by. When you differentiate cos, what are you going to get? We are going to get, when you integrate cos, we are going to get sine. So we are going to get sine ax, and then don't forget plus your c. So take very good note of it. The same thing, if you did your differentiation well in calculus 1, you can see that when you differentiate sine x, you are going to get cos x. That's it. So basically, as I said, it's a reverse of differentiation. So if you know one, you know the other one as well. So the next one is integral of sine ax dx. So if even you don't remember, one thing that you can use as a trick is that look at how we differentiate that particular function. So when you know the results, when you differentiate that particular function, you can get the reverse of it, right? So integral of sine ax, as I said, differentiate whatever is inside the bracket and you divide. But you need to figure out whether it's negative or positive. When you differentiate cos x, what do you get? When you differentiate cos x, what do you get? You get negative sine x, right? When you differentiate cos x, you get negative sine x. So if you are now integrating sine x or sine ax, what are you going to get? You are going to get negative 1 over a, as I said, and then cos ax plus c. So if you want to verify this, let's use our differentiation techniques to do that. So we have 1 over a cos ax plus c. So in differentiating, finding the dy dx of it, finding dy dx of this one, we differentiate whatever inside here and we multiply by the function itself, and we differentiate the cost. As I said, when you differentiate cos, we are going to get negative sine x, or sine, right? So now we are going to get negative 1 over a multiplied by, when I differentiate whatever is inside, I'm going to get a. And then when I differentiate the cos, I'm going to get negative sine ax. And therefore, this a will cancel this a. This negative here will go for this negative here. And now finally, we are going to get our sine ax. So in this case, when we integrate sine ax, the result is negative 1 over a cos ax. So this one actually confirms this standard integral. So basically, let's move on to the next standard integral that I want you to know. It's the next standard integral that I have to know. It's the integral of sec square ax. Let me write it well. The integral of sec square ax dx. So as I said, they are standard integrals, so they should be in your fingertip. Wherever you encounter them, you just write them straight away. So 1 over a tan ax plus c. This tells you that when we differentiate tan x, we get sec square x, right? So based on the fact that there's a coefficient in front of the x, you need to differentiate whatever is inside the bracket. You divide by it, and then you take its integral as well. And don't forget to add your constant. So the next one is differentiation, integration of cosec square x, or cosec square ax dx, which is equal to negative 1 over a cot ax plus c. So this is another standard integral. The next one is integration. The next one is integration of cosec ax cot x, or cot ax dx is equal to negative 1 over a cosec ax plus c. Don't forget that. And then the 7. Let's look at the integral of sec ax tan ax dx, and is equal to 1 over a sec ax plus c. And then the 8th, have integral of exponent ax dx. This is an integration of an exponential function, right? As I told you the other time, I was saying that when you get an exponential function, they ask you to differentiate. You differentiate the power and you multiply by it. But when they ask you to integrate, you differentiate the power and you divide. So in this case, we are going to get 1 over a multiply by the function itself, exponent ax, and then don't forget to add your plus c. And then the last one that I want to give it to you, it's 1 over x dx, which is equal to ln x plus c. So these are some few standard integrals that I want to discuss with you guys. And as I promised earlier on, I'll take time, or I'll find time and actually take them one after the other, especially the ln functions, the trigonometric functions, and that of the exponential functions. Break them down one after the other, both the integration and the differentiation, in such a way that if you are comfortable working with them, you will not be afraid in working when they combine them to form a question for you. So thank you. And then if you want more of these standards integral, you can go to course online. There are a lot of standards integral that you have to keep in your fingertips. And then before you can keep in your fingers, you don't have to memorize, just keep working examples, and with time it will stick in your fingertips. Anywhere you see them, you'll be comfortable with them and you know what it will be. So thank you, and see you in my next video.